Okay, so guys, here you should calculate what the total resistance. For you to calculate the total resistance, you will only focus on the resistors only. Leave these, leave all of them, because these one are what to call measurements, by the way. This is a ammeter, and this one it's a voltmeter, this one it's a ammeter. A voltmeter, it measures a voltage there, and ammeter, it measures a current. So for you guys to calculate total resistance, just focus this circuit like a circuit like this there. So this, it's a cell, this it's a cell, this it's a cell, this it's a cell, but when they combine together, they form a battery there. Let's only focus on resistors there. So this, it's a resistor, this it's a resistor, it's a resistor there. Yeah. Okay, yeah. Okay. So if you can notice something here, guys, if I can remove all the measurements, I will only have resistors there. So for you guys to calculate the total resistor, you should simplify this circuit. You should start by combining these two things together, because those two things, they are in parallel there. So it simply says that you can say parallel, which is 1 there, which is equal to 1 over R1 plus 1 over R2. This one I will name it as R1, R2, this is R3 there. Yeah. So the equation that I just used there is this one there for a parallel circuit. So what I will do there, I will substitute here. I got 1 plus 1, and here it's RP. So what I will do, I will press this thing on my calculator there, which is 1 over 1 plus 1 over 1. So I got 2, as you can see. So it simply says that here it's 2 1 over RP. But guys, here you are solving that RP, meaning you should make RP to be alone. We should remove that one. For you to remove that one there, you can take -1 both sides there. By you taking -1, that one will get removed. This thing will be RP, and now you can come and press your calculator, which is 2 -1. Do you see what I got? Yeah, this is what I get there, meaning here it's 1 over that, but leave your answer in decimal, guys, meaning it's 0.5 ohms. So what does this thing mean to you? This thing, it simply means to you that when I simplify this circuit will just become like this now. It will become like this there, which is ohm. So here I will have what? I will have 0.5 ohm there, which is RP, and this one it's R3. Do you see? This one it's 0.5, and that one there it's R3, which is still that one it didn't affect it. So now you can get a total resistance by combining both of those two things there as your total, meaning that your total resistance now will be R3 plus RP, and that RP you already calculated, which is 0.5. This one it's 1 plus 0.5. So it simply says that the answer here is 0.5 ohms. So that circuit there, when you simplify it, it will become as, here it's 1.5 ohm. This is the total resistance, which is, yeah. So that's how the circuit will become when you simplify it. That's how you simplify a circuit. You only focus on those resistors there. Do you see? So now the next question will simply say to you, calculate the total current in the circuit there. For you guys to get a total current, since you know what a total resistance, and also you are given from that statement there is something that I didn't read for you. Here's this thing there. They told you something here. They say that the following circuit consists of 3 identical resistance of 1 ohm, each a voltmeter, and as shown in the sketch there, as you can see. But there is this powerful statement there that you should take note of. Okay, let me read it here, that one. It simply says that 4 10 volts cells are connected in series to create a 40 volt there. So it simply says that we've got 4 cells which all contain, all these are the cells, they got 10 volt, they got 10 volt, they got 10 volt. All of them, when you combine them, they will create a battery of 40 volt there. Do you see? So this thing, by the way, it's your total voltage there. It is the voltage of, it is the combination of each cell there. They create a volt of 40 there. So this one, it's our total voltage. Symbol says that I got the total voltage then, and here I already got the what? I already got the total resistance there. So let me write that voltage here. Let me write here, this thing it's volt, this one it's 40 volt, which is as well as here it's 40 volt. So from this equation, guys, there is this equation that I show you, which is what you call Ohm's equation. This equation, you only do it only if you are focusing on one component there. If you are focusing on only one component, that's why you can apply Ohm's there. So let me show you here. I will be only focusing on one component, which is a total resistance there. And here I also got a total voltage. What I need there, I should get a current that is flowing through there. That equation, it's like this there. It's V over what? Over I. There I got the voltage, a total voltage. I got the total current. This is what I need. So for me to solve this thing then, I can substitute them. This it's 1,5. Here it's 14, which is current then. So what I will do there, I can put invisible 1 here. Because those two things, guys, they will multiply each other, I can just flip them. Meaning that I can flip them, become like this, 40 over 1,5. And here I'm still having that invisible 1. Do you see? But a denominator, guys, which is 1, we don't write it. No need for you to write it there. So the only thing there that you're supposed to do, you can just flip those two things so that you can solve that I there. Or you can even do cross multiply there if you understand cross multiply. But this thing is still one and the same. Flip those two things, give you that. Meaning now my calculator there, I will press this thing, which is so this is what I get there on the calculator, which is there, it's 26,67 amperes. Yeah. So this is how, guys, you calculate this. It's a total current. Meaning that the current that is delivered by the battery, it's 26,67. 26,67 there. So even here, that current there which is delivered, it's 26,67 amperes, which is 26,67 amperes. It's delivered here. It is delivered through that current there that is delivered, it's 26,67 amperes. Now, even here 26,6 amperes there. So if now you know the current that is delivered by the battery, so this is the current that is delivered by the battery. It will move, it passes through that ammeter, it goes through this resistor, then it goes. But when it reaches here, guys, it will get divided. It will go here and come there. Then it goes through there, it goes through there, it goes through them. Yeah. Then it come again on this point, it combine there. It get combined. And that current there, I already solved it. It's 26,67 amperes. 26,67 amperes. Yeah, here it's 26,67 amperes. But guys, be aware, when the current reaches here, the current, it won't go through a voltmeter. Yeah, a current won't pass through a voltmeter. A current, it only pass a resistor and a ammeter there. Do you see? So it means that it will pass the resistor, it passes the resistor and the ammeter. It doesn't pass through a voltmeter. Take note about that. So now the next question will say to you, it will say that give the reading on V2 and give the reading on A2 and A3 there. Where is A2 and A3 there? So when they need a reading on A2 and A3, they need you to identify the current there that is measured by this ammeter. They need for you to determine the current that is measured by this ammeter there. And for you to determine that current, the first thing that you should know is the voltage there across here. If guys you can know a voltage across those two resistors, it will be easy for you now to get the current here, because there you will know the voltage, you will know the resistor, then you can get the current by using Ohm's law equation. So what I will do there guys, for me to get that voltage then, I will come where I combine those two things there. That's why I combine them here, meaning that I can get that voltage then, RP. I can get that voltage there because I know now the current which is flowing through here, which is flowing through there. I know that current, I know the resistor, then I can get the voltage there. So this is how you will get that voltage there. You will just say, let me open this here. So for you to get that voltage, this is how you will get it. I will only focus on this circuit there. I'll say there it's ohms V over I. So so now when I substitute guys, I will focus to the parallel resistance and the parallel voltage, and here I know the current there is the one which is through there. Do you see? So there it's 0.5, which is VRP, and 26.67 there. So now I shall solve this now. So put invisible one, so this will multiply here, this will multiply there. These two things will multiply each other, it will be V. Those two will multiply each other. So now you can punch your calculator, 0.5 multiplied by 26.67. Yeah, so this is the answer that I got there, which is 13.33. Okay, so this thing, it will be 4 volt. So this voltage that I just got now, it is the voltage across the parallel resistance there. Parallel resistance, that is the voltage. What does that voltage mean to you? It simply means that that voltage there is the one which is across here. It is also that one there. It's 13.34 volt there. So that voltage there, it across the parallel resistors there. Do you see? And the voltage across the parallel resistors, it will be equal with this voltage, also equal with that voltage there. Do you see? So it simply says that I can just only focus on this component there. I can only now focus on this component, that one there. Try to get the current which is passing through that ammeter there. So for you to get that current, you still use Ohm's law there, which is V over I. Then when I substitute there, I know that the resistance there, it's 1. The voltage there is the one that I just got there, which is this. The current there, I don't know the current. Do you see? And now I shall solve that current. That current there, I can put invisible one there. Because those two things, they will multiply each other, I can flip them. This will come here, and 3, 4. That one will be here. That invisible one is still there, guys. But now what you should understand is that in maths, you don't write a denominator which is 1. You remove it. Even here, there you can press this thing on calculator. it will still give you this there, because we don't write a denominator in maths, which is 1 there, which is this comma this over 1. Do you see? I still got the same answer because we don't write a denominator, which is 1 in maths. So this, it's your final answer. It's V, which is 13,34. And we are talking about current 2, by the way. There, it's current 2. And there, which we use that thing there. Do you see? So it is so important